What's up, math scholars? I have the best, happiest news in all the land. We are doing the last lesson of the year. So, who's excited? Yeah! We survived the year. You guys are headed on next year. I'll miss you. Come back and see me every single day. At least once per day, if not 10 times per day.
Once per day?
Yeah. Alright, did everybody go ahead and tape in the little slip of paper they got today?
Nope,
So let me show you what's weird about this slip of paper you taped in. Normally you have like one choice for sine, one choice for cosine, and one choice for tangent, that's it. But look, the double angle for sine has one formula. The double angle for cosine has 3 formulas. What? And you actually can pick and use whatever formula you want. They would all work out and they would all give you the same answer. That's really cool. And then the double angle for tangent, you only have one choice. Thank you. Right there. So, let's go ahead and read the prompt. Use the double angle formula to show the value of sine 60. Now, I'm well aware if you need to find sine 60, you could probably just look at the unit circle, right? So we're basically today just proving that these double angle formulas do work and they give the right answer, okay? So before we start, let's just see what is the answer of sine 60 so we know. Radical 3 over 2. Yep, I agree. So let's actually just use that double angle formula to prove it gives that same answer of radical 3 over 2. So our first job is just to select what double angle formula we'll be using. So look on your slip of paper, which one would we be using? The one for sine. So it's 2 sine A cosine A. We do need to figure out what A is. So since we're trying to find the sine of 60, we actually can rewrite 60 as 2 times 30. And that just means our A value is going to be 30. Does that make sense? So everywhere we see an A in the formula, a 30 is going to go in. You know what time it is? It's unit circle time. What's the sine of 30? 1/2. What's the cosine of 30? And then we're just going to kind of simplify down our fractions. This 2 is technically a 2 over 1. And 2 over 1 times 1 over 2 would cancel each other out and just give me a 1. So my answer is exactly what we expect it to be. We just kind of sort of verified the formula worked. Okay? All right, we're going to do the same thing, except this time we're going to kind of verify that a cosine double angle formula would work. What cosine double angle formula would you guys like to use? There's 3, and it doesn't matter which one we choose. First one? All right, I heard somebody say first one. So we will use 1 minus 2 sine squared A. So cosine of 240 could be rewritten as cosine of 2 times 120. That's why it's called a double angle formula. You just select whatever angle that you would double to get 240. So 120 is the angle I would be doubling. So my A value is 120. Make sense? Everywhere we see an A, we're going to put a 120 in. Alright, so it's unit circle time. Let me explain. We're going to grab the sine of 120, and then we're going to square that number. So what is the sine of 120? Radical 3 over 2. So we're going to end up squaring that. Radical 3 over 2. All right, so let's talk about how that squared would affect the radical. This squared would cancel the radical with a 3, so that's just going to be a 3. And then the squared would also go to the 2, so that's going to become a 3 over 4. Does that make sense? And then I'd probably just type it in. It's going to be 1 minus 2 times 3/4, or 1 minus 6/4. The easiest way to do that is probably just type it in the calculator. Hit fraction at the end. All right, wait 1 second. 1 minus 2 times 3/4. Hit fraction at the end, negative 1/2. All right, this time we get to try a tangent one. So there is actually only one choice for a tangent double angle formula. It is 2 times tangent of A over 1 minus tangent squared of A. Can you guys tell me what my A value is going to be? 120 again. So everywhere we see an A, we'll put a 120 in place. So 2 times tangent of 120 over 1 minus tangent squared of 120. Now, I want you to talk about what tangent of 120 is. I'll give you a second to let me catch up. I don't want to go too fast. All right, so to find tangent of 120, you're going to go to 120, grab that y value, and grab that x value, because you'll need to divide them. So what is the y value at 120? Positive? Yep, positive. Good. And what's the x value at? Perfect, negative. So what ends up happening is these 2's can cancel. You can multiply by the reciprocal, the same thing would happen. But it's a negative radical 3. So basically we'll have a negative radical 3 to put in everywhere we see a tan 120. Does that make sense? I'm going to shrink that down to give myself some workspace. Sorry. So the question was, how did I do this whole simplify thing? If you have your top number, you can always multiply it by the reciprocal of the bottom number, and the 2's cancel. See it? But I just kind of slashed the 2's, it's the same thing. There's no 6, though. If I did it, I would have negative 2 radical 3 over 2. You can never make it a 6 because the 2 is not in a radical. Alright, so now everywhere you're seeing that tan 120, I'm putting a negative radical 3 in its place. So there's a negative radical 3 here. And it's 1 minus negative radical 3 squared. That is a tricky little guy to simplify. So we'll talk through that slowly. He's a tricky little guy. So on the top, it'll just be negative 2 radical 3. That's not hard. The bottom is where the simplifying becomes hard. You always have to square things before you do anything else. And a negative times a negative would be a positive. And what would radical 3 times radical 3 be? Just a 3, right? Because it becomes square root 9, which is 3. So my bottom is basically 1 minus 3. So if I have a negative 2 radical 3 on top, and I do 1 minus 3, I get negative 2. Those negative 2's can go away. This is just a kind of wild ride as far as the simplify process on this one. No, this is not the long problem. All right, this is the one that's slightly longer. We're going to use the same strategy we used last week. We are recording if you keep it down. Okay, so anytime they start you off with some given information and they start you off with cosine, and you know that you're going to need to find sine eventually, your best bet is to start with that Pythagorean identity. Do you remember it? Sine squared A plus cosine squared A equals 1. Those really long problems we did at the end of last week, Thursday and Friday, are exactly like this, where we use those Pythagorean identities. So we're basically going to be plugging cosine in and solving for sine. Now, I didn't chat about quadrants yet. I do want to have a chat with you about quadrants. They tell us that angle A is between 3 pi over 2 and 2 pi. What quadrant would that be? 3 pi over 2 and 2 pi. We're in between. Quadrant 4. Good. And that would mean my cosine value is positive, but my sine value is negative. So before I even start, I know my answer will be negative. At this point, I would probably work on squaring that 5 squared over 13 squared. So that would be 25 over 169. That 25 over 169 can subtract over to the other side. So I'm just going to do it in the calculator, but not write it down. 1 minus 25 over 169. And I like to hit it up with a math enter at the end. It'll be, to make it a fraction. 144 over 169. I sure like the side of that, because those are perfect squares. So wheat. Square root both sides. And we did chat that angle A was in quadrant 4, so my answer is negative. 12 over 13. The square root of 144 is 12. The square root of 169 is 13. So that information, along with this given information, is enough to help me do what I need to do. So here's what I need to do. I need to find cosine 2a. So we need a double angle formula. What double angle formula do we need? 2 sine A cosine A is what the formula is, I believe. Check me on that. Going off my memory. So basically everywhere we see a sine A, we'll replace it with a negative 12/13. Everywhere we see a cosine A, we'll replace it with a 5/13. So we're substituting in the values that we had solved for. And at this point, I use my calculator and I just hit fraction at the end. So 2 times negative 12/13 times 5/13. Math, enter, enter. Negative 120/169. Last one. We're going to be doing a little solving on this one, utilizing our zero product property in that process. So first things first, why do you think this even falls into the double angle formula lesson? It has to do with this right here, sine 2x. Sine 2x is where we're going to have to utilize a double angle formula. We're actually going to replace sine 2x with his equivalent form in the formula. So look on the formula sheet. What does sine 2x equal? 2 sine x cosine x. And so now that sine 2x is gone, I can solve this normally like we solved them last week. I think it was the day the sub was here we watched the lesson on using the zero product property. So to use the zero product property, you first have to use common monomial factoring. So I have two terms, this term and this term. What do they have in common that I can divide out front? A 2 and a cosine, leaving me with a sine and a 1. Technically, yeah. Technically, there's a little time symbol there, but I normally don't write it. Zero product property time. If this times this equals 0, one of the two has to be 0. So either 2 cosine x is 0, or sine x plus 1 is 0. And we solve both branches, and we use our unit circle to kind of help us solve. So on this branch, I can just divide both sides by 2, but that's still going to be a 0. Where on the unit circle is there a cosine value of 0? There's two places. And I'll just go with pi over 2 and 3 pi over 2. We seem to be working with radians recently. And then over on this branch, subtract 1, subtract 1. Where on the unit circle do you see a sine value of negative 1? 3 pi over 2, which we actually already have that answer on our list, so I don't even need to circle it. Yeah?
Why would you not have to do like the plus?
Well, thanks for watching my very last video lesson today. I guess we'll be making a study guide video, but this is our last lesson. The homework is at the end of the file. This is, if you look in Polaris, I put the notes as PDFs, and it'll be right here, so you can find it, okay? Sound good? Have a nice day.